So I've been looking at microphone preamps based on the 990 op amp, which are these things here. They're op amps built on discrete components, and then they're epoxied in to a shell. So here's the bottom of one. And then below here is just a normal op amp 8-pin dip package, more traditional type. So while looking at the datasheet for this John Hardy 990 op amp, found this figure 2 that shows a comparison between 3 different capacitor types, showing the total harmonic distortion versus frequency. And then the test circuit is a high pass filter. So there's a capacitor and then a 1K resistor to ground. You have a 3 volt RMS source and then a meter on the other side. And then the other circuit, basically the same thing, but it's a low pass filter, so the capacitor and resistor are swapped. So I thought the results were interesting. The C0G type had so little distortion, it's basically in the noise floor for most of the range. So to recreate that circuit in the diagram, I designed these little circuit boards with SMA input and output. And then there's room for 3 parallel components and 2 series, so I can use these for multiple uses, different filters or attenuators. And so this board I have populated with the low pass filter. It's a series resistor 1K and then a capacitor to ground. So this top one is the C0G. The middle circuit is X7R. And the bottom circuit is only the resistor. And then I'm going to start with this to get kind of a baseline measurement without any capacitor. And then that'll give me basically the noise floor of the instrument with this setup. And then I can swap these connectors to the different capacitors and then get a good comparison. So here's the test setup with the instrument I'm going to use. It's the HP 8903A audio analyzer. Goes from 20 Hertz to 100 kilohertz. It's got an output, and then on the other side it's got an input which can measure whatever you're feeding through the circuit. And you can select manually frequency 1000 Hertz, and then you can set an amplitude. In this case it's 3 volts, and right now I have it set to, this is total harmonic distortion, and then right now we're measuring 0.0027. So this can also do AC level. Then I can do like a frequency response graph. So to help make these measurements, I wrote this Labview code to automate the testing. So I have this main tab where I can create a project, create a test file, name the traces, set the parameters. Got level here set to 3000 millivolts, so that's your 3 volts. Click that and it sets it. Then I've got start frequency 20K or 20 Hertz, stop frequency of 20,000 Hertz. And then this is how many data points. 10 seems to be enough. And to start with, I'm going to do a AC level. I'd rather do it in volts. I'll do it in decibels. That's more of a common way to look at the amplitude. So to start with, I'm just going to get the frequency response. First of just the through measurement of just that 1K resistor in series. So that should be very flat. It'll just be the response of the instrument itself as a baseline. And then I'll do the X7R and the C0G, which should be basically the same because they're the same component values. But this will just show that the circuit is working as expected. So I'm connected to this bottom one, which is just the through measurement. It's just a 1K resistor in series. And I'll click run. Then it'll automate the sweep. And this side is the voltage in dBV. And on here I've got a little preview graph. And once it's done, I can go to the main graph. Okay, so that's done. And here's the response. Looks a little strange because it's so zoomed in. The voltage here is barely different from the top of the scale to the bottom. Okay, so now I've got the second one hooked up. This is the X7R. Typed in the name here, then I'll hit run. Okay, and here's the result. The X7R is the blue trace. Right in the middle is 1 kilohertz. Slopes down like a low-pass filter should. And then the black line is our baseline. Now that it's zoomed out, the black line looks perfectly flat. Then I'll just go to the C0G type here. Okay, now I've got the C0G hooked up. C0G entered, and then I'll hit run. Okay, so that sweep is done. And that's the orange trace. And being that they're the same capacitor and resistor values, the results are basically the same. So now, knowing that the circuits are okay, I'll switch over to harmonic distortion. And we want distortion %, so I'll select that. So here you can see I'm connected to the bottom one, which is just the 1K resistor feeding straight through with no parallel capacitor. This resistor on the other side is just a 0 ohm jumper. And then I'll run the distortion % sweep. Okay, and here's our baseline zoomed way in. And I'll switch to the X7R. X7R is plugged in. I'll click run. Okay, the X7R is done. Take a look at the graph. Goes up to about 0.1 in the middle. Now I'll switch to the C0G. Name is entered. Click run. Okay, that one's done. I'll go to the graph. That's the orange trace. It basically overlaps the black trace, except at the very top end it maybe goes up a little bit. Okay, so comparing the graphs, the C0G basically right at the bottom, similar to this. And then the X7R